Okay, so for the second part, what we're going to look at is purifying it by recrystallization. So acetanilide here is one of the few compounds that really soluble in water at high temperatures, but pretty poorly soluble in low temperatures. This isn't true of the aniline and the sand. So the aniline, that's a decomposition product of the acetanilide with water, we can easily pull that out, unlike solvent extraction. The challenge here is that we have to dissolve it and then crash it back out. So we're going to start with our starting mixture of acetanilide sand. We're going to carefully pour it into the flask, and we're going to add our 50 mLs of water. Now, unlike with the ethanol, you can see where this just really isn't dissolving in the water. So what we're going to do, we're going to stick it on a hot plate, fairly good heat, 7 to 8, and what we're going to do is we're going to let this dissolve in water. Now, there is a trade-off here. You don't get something for nothing with this. The aniline here is going to, the acetanilide here is going to react with the water, start producing aniline. So we are going to lose a fair amount of our, well, I should say a fair amount, we lose some of our material to just this whole process of heating it up and boiling it in water and cooling it down, especially if there's any acid present in the water, which is what we expect. So I'm going to cut the video here just for time. I'm going to let it kind of get to a boiling off screen, and then when we come back, we'll take a look at what happens when we add the activated carbon. It's a lot hotter than I thought it was going to be. So if we take a look at it, we can see the grains of sand. I'm not really seeing a lot of aniline in this particular sample, but we're still going to add a little bit of activated carbon. Now, with the activated carbon, what we work with are the rods. And the reason we want to work with the rods is they're a bit easier to manage in terms of filtering. So if I throw the rods in there, that bubbling you're seeing there is not actually a reaction. Part of it's just the air leaving the carbon black. It's a very high porosity material. The second is that this is still very hot, so you're kind of seeing a boiling effect. So now that we've got it filtered out, what we want to do, well, now that we've got it, dissolved, the next thing we want to do is we want to filter out our material. So give me just a minute. We grab a funnel. So with gravity filtration, again, what we're going to do, take it, fold it into quarters. And we're going to open up one of the quarters. And now we've got a nice little funnel. Now the challenge here is that if this material begins to cool, what we'll end up getting is the crystal crashing out in the filter itself. So what I'm going to do to the side here, while we're filtering, is I'm going to heat up some hot water. Roughly 50 mLs worth, or how much does it call for? And we're just going to pour it right through, see what happens. So let me turn the camera down. Now this is good and hot. If you wait too long, it will start crashing out the filter. Now it's okay if the sand and the carbon black get in here. That's kind of the point of the filter. Oops. Sorry about that. So you can see it went right through. And already in the bottom of this flask you can kind of see, it's a little hard to see with all the steam, but there's already crystals starting to crash out in solution. So to kind of drive this along, I'm going to use some ice water. Now with the ice water, a common mistake I see students is they kind of add ice as if they're making a drink. You're not making a drink, you're making an ice bath. An ice bath should be 1-to-1 ice to water. So I got a ton of ice in here. The other thing is I don't want to fill the thing with ice water. And the reason I don't want to fill it with ice water is I've got to make room for that flask. Take it. drop it in the beaker, and I'm going to cut the video so this way you can see what it looks like after it's had a few minutes to cool. I don't think you really need to watch that.